So I get hot, like really hot, like really really hot when I'm trying to sleep. So hot that I will actually freeze 2 liters of water and try to snuggle that to help cool me down in the middle of the night. Um, but I wake up in the middle of the night, well, several hours throughout the night, and to find that the frozen 2 liters no longer frozen, but is now body temperature. So I'll actually have two liters that I'll swap out throughout the day or throughout the night to help cool me down. And I've tried like little water bottles for just little moments, but I was doing that so often. I just thought, well, what if I constantly swapped out the water instead of having discrete times where I'd swap it out? I wouldn't need such cold temperatures. And so I water cooled my bed. I got a computer. Got a computer radiator, pointing at it. Got a computer radiator to bring the water back down to room temperature. I've actually moved tubes all throughout my my bed up and down here to bring my body temperature, or at least the bed temperature, to ambient. And then I have a little centripetal pump to move water back and forth to allow for circulation. And that was wonderful. Oh, it was beautiful. Because I'd wake up in the next morning, and instead of my back being on fire, it would be room temperature, and the bed would be cold or room temperature, and my back would be beautiful. But one of the issues with the pump is that it died a lot. Now I'm not sure if it's because of the hard water that we have here, or if it's because of chemistry between the aluminum radiator and the copper inside the motor of the pump. It was a submersible pump, super cheap thing from Amazon. I would try more expensive ones, but I don't want. I wanted a certain size so it would fit in the thing that I'm wanting. I also needed to have certain fittings so I didn't have to go through a bajillion different fittings, and there was some third criteria, but I couldn't find anyone that would have all three of those things that I'm looking for. Like, I could find ones that had the right sizes and were more expensive and probably of higher quality, but they'd be 120 volts. I don't want 120 volts. I don't want water coming close to me to I know it should be fine, but it'd be 12 volts. So it's what I want. And so the pumps keep dying. Sometimes I'm able to revive it, but basically they just die. So I began looking into a peristaltic pump, and those are nice because they don't touch the water at all, and they can just keep on going and going. So one of the big issues with that is that this tube here, I don't think it would be able to withstand the highest pressures, and peristaltic pumps can have really high pressures because they can really clamp onto the tube, and so yeah, they can create really high pressures and probably cause damage or break or explode my my setup. So I wanted to stay away from high pressure ones. I couldn't find any ones that were deliberately low pressure that looked feasible and were not super cheap. If I couldn't get a low pressure one, maybe I could have like a bypass. Like if the pressure ever did spike, I could just have it bypass back into the tank. So that it won't. I also have a reservoir. I don't know if I mentioned that. So the pressure would never get too high. But I found online. I found a homemade one where they used a spring on the rotor. If you don't know what a peristaltic pump is, I should probably talk about what that is. A peristaltic pump is it's a pump that, if you can imagine me grabbing onto this and then squeezing my hand, I can force the water in one direction. I can force it towards my thumb if I do it like this. I'll start with my pinky and then squeeze it up towards my thumb, and the water will keep moving in that direction. And that's basically what a peristaltic pump is they just they squish, they'll pinch a tube and then just force the water around in a circle. I guess I'll show you that in a second. But yeah, I saw one where they, instead of having a fixed, very stiff rotor, they had a rotor with springs on it. But it was rather large. The springs were really big, and it was not quite what I was looking for. But I thought, well, I have experience in compliant design. I could probably whip something up that would at least do kind of what I needed to. And so I came up with this here. It's a little rotor that this is just a test piece, but this would not be able to push very hard on the walls of the oh, what's it called, of the tube. And if the pressure ever got too high, it would just push this back. So and it would never get to the high pressures to begin with. So and this was actually really really nice what I was looking for. I'll talk a little bit about the design of this. I wanted something that would move like roughly 5 millimeters, centimeter across its stroke, and I want it to be like within a fifth of the stress required to permanently deform it. So it's like that's well within its range. It shouldn't. This theoretically would have an infinite lifespan, unless other factors come into play. And I also wanted I wanted it to be a spiral, but it didn't. It was kind of a pain to get to work as a spiral, so I did a 2-step spiral. So instead of an infinitely continuous spiral, this is chopped up into 2 circles. So there's a circle. See if we can see that. There's a circle here that is tangent to a circle here, and they both meet up at a single point and are tangent to each other. Like a perfect spiral would have infinitely many of those, but this one just only has 2 per branch. And I also, if you can imagine that if the cross section was the same, like if I had a beam that was the same cross section, and then you began to load it, you'd get a lot of forces right at the shoulder or midway through, depending if it's bending or the different types of stresses that you have. You'd get different stress concentrations at different areas. But I wanted it to kind of all be at the same stress. I didn't want any single point to be taking all the load. So as you can tell, it gets progressively thinner. It gets progressively thinner towards the tip, and I designed it such that it's really even across that entire shape. It's not perfectly even because I wanted the base to also be able to withstand moments, so it's a lot thicker. And moment is just a torque. Yeah, so that's that piece there. All right, and I guess I'll just go ahead and show you. This is the actual peristaltic pump that I made. I don't want to take it apart, but I'll show you what one similar to it would look like. So let's see, can I come around? So as this thing would spin, I would have the tube come in like this and go around, and it would pinch the tube against the sides of the walls and spin it around, and it would pinch the tube and force the water to go in one direction. And yeah, I have taken a video of it inside of this one. That's a different one. It's a lot bigger because I was running into some tolerancing issues. Yeah, this is just a little housing that I had for it. But yeah, this thing would like spin in the middle and move the water around as it went around. But yeah, I want to test it out tonight. I think it'd be really cool. Seems to be going fine. It's been going for about, I don't know, maybe half an hour, I think. And I currently have it running as slow as possible. I can have it run faster if I put it over here. Yeah, it can run a lot faster, but that might put undue on it. Put it down. Oh yeah, and that's just lazy man's, not even a poor man, just a lazy man's power limiter. I just put a bunch of resistors in series. Yeah, it's just lazy. Because I don't want to. I currently don't have my voltage source. It's used up and it's in a different state. But I mean, it gets the job done, and none of the resistors are beyond their power limit. Yeah, so that's my project that I've been working on. My peristaltic pump.